topic of this video is depth first search. How depth first search works is it lies in its name. It explores in depth. And in both depth first search and breadth first search, we have an initial node from where the search begins. And we are basically finding a goal node. In this scenario, the goal node can be Faisalabad, it can be Multan, or it can be Quetta. This is our tree. In our tree, Karachi is connected to Lahore, Islamabad, Multan, Peshawar, Quetta, and Faisalabad. So how depth first search works? Depth first search initially starts from a starting node and it explores till there are no more neighbors. And initially, if it starts like from Karachi, it explores till there are in depth. This is the depth, leftmost depth. And after Quetta, there are no more nodes. Quetta has no further branches or no further neighbors. So it explores till Quetta, and then in depth first search, we have a concept of backtracking. It backtracks to Peshawar. Peshawar has no node, further node, or no neighboring node that is not explored. It has only one child node, and that's been explored. So it goes back to Islamabad. And Islamabad is the only node that is connected to Peshawar, and it has no other neighbor. Then it goes back to Lahore. Lahore has another neighbor that is not yet explored. So it moves again in depth wise. It goes from Lahore to Multan, and from Multan, there is a child node that is Faisalabad. It explores this node, and then it goes backtracks to Multan. Multan has no further node that is not explored. Lahore has no further node that is not explored, and then it goes back to Karachi. This is how depth first work. In this situation, we have Karachi, Lahore, Islamabad. After Islamabad, we have Peshawar, then we have Quetta, and after Quetta, we have is Multan, and after Multan, we have Faisalabad. This is how depth first search works in this scenario. And let's assume that in this scenario, we have Karachi as our initial node and Faisalabad as our goal node. So this is how depth first search will work. Our goal node can be different. It can be Peshawar, it can be Quetta, it can be Islamabad. So when goal node is achieved, it stops there and it doesn't explore any further nodes. So let's also understand how in depth first search, the last in, first out approach works. Sorry. So how it works? Let me explain this last in, first out approach, how it works. So in last in, first out approach, the first node that is added in our queue is Karachi. After Karachi, the next node that is added is Lahore. After Lahore, the next node that is added is Islamabad. After Islamabad, Peshawar is added, and after Peshawar, Quetta is added. So this is what our queue looks like. After this step, the next step is there are no further nodes after Quetta, so it stops here. And last node that is being added will be the first that will be removed from this queue. And there is no memory that should be retained in this because of this approach, last in, first out approach. Why? When Quetta is removed from the queue, it comes back to Peshawar. And when Peshawar is removed from the queue, it comes back to Islamabad. So there is no need to retain the memory. And after Islamabad, it comes back to Lahore. Now, at this point, Lahore has a neighbor that is not explored. So after Karachi, it explores the other neighbor of Lahore, that is Multan, and Multan has a child node that is Faisalabad. This is how depth first search works. So when Quetta is removed, Peshawar is removed, Islamabad is removed, and in our queue we have this sequence that is Karachi, Lahore, Islamabad, Peshawar, Quetta. When Quetta is removed from this queue, Peshawar is also removed, Islamabad is also removed. Then the other neighbor of Lahore is explored, that is Multan. And after Multan, its child node is explored, that is Faisalabad, and this is how the list of visited nodes, this is list of visited nodes is made. So the important points in depth first search is our starting node, that is Karachi, starting point, and our goal node, and the sequence in which it moves. So now we go further and check time complexity. How time complexity works, it works with like V plus E, where V is the number of vertices, E is the number of edges. Let's check how many vertices and edges we have in this situation. We have vertices equals to 1, 2, 3, 4, 5, 6, 7. 7 vertices, and edges are equals to 1, 2, 3, 4, 5, 6. So 6 plus 7 is what is the time complexity. So if we have more vertices and more edges, then the time complexity will increase. in this scenario, meaning that if we have more branches, then depth first search is exploring apart the left side branch. The unnecessary explore is being done, and it's not exploring the other nodes. If our goal is here and there is a long depth here, then it means that depth first search is wasting time here and not searching here. So let's check the pseudocode for depth first search. This is a pseudocode. Pseudocode is very simple, very easy. First we have is the depth first search basically takes two arguments, that is graph and root. Graph is being given to depth first search and root is initialized. In this scenario, we have Karachi as our starting node or our root from where the search begins. And it calls depth first search. It's basically calling depth first search function. What is happening in this function? Basically takes three arguments, that is graph, node, and visited list. The visited list is being marked and it's being stored. And after that, we have two loops. First is for loop, and then we have if loop. In for loop, basically, it's checking if there are further neighbors or not. It means like this. I'm just taking a random example. In for loop, it's checking if there is any neighbor or not. And in if loop, it's basically checking that their neighbor is not visited. It means that in depth first search, it explores in depth until there are no more visited nodes. It stops there and then it checks if it backtracks and checks if there is some neighbor or not, and then backtracks. And here, when there is a neighbor, it explores that neighbor and add it to the list of visited items. That's how our depth first search works. It has for and if loop. For loop is checking if there are neighbors or not, and if loop is checking that the neighbor is visited or not visited. If the neighbor is not visited, let's see code. In this code, we have DFS. That is our function that is defined, and it takes three arguments, graph, node, and visited list. So it explores in depth twice. So it starts with an if node. That is, it starts with the if loop, and it starts from a node that is, and explores it in depthwise till there are no nodes, and add it in visited list. Then we have a for loop. If there exists some neighbor, then explore it in depthwise till there are no neighbors in the graph. This process is repeated till there are no neighbors, and for each neighbor, its depth is explored, and every node is added in the list of visited nodes. So the three arguments that are being taken are graph. Here our graph is being defined. A is connected to B and C. B is connected to A, D, E. Take some time and make this graph. And then we have list of visited nodes that is initially set as empty. There are no nodes initially in this list. When a node is being visited, it's added in this visited list. So DFS takes three arguments, graph, node, and set of visited items. The node, initially, our starting point is set on A. It can be different, it can be C and D. And when we change our initial point, then the traversing is different. We can also set a goal point here. It can be F, it can be E, it can be C. If we have not written our goal in our code, then basically it understands that F is the goal. And from A, we have to move till F. Now let's see the graph of this code. Here is the graph of this code. So this has A as initial node, and after A is connected to B and C, and so on. So how our DFS basically works. So in our DFS, the traversing will be like this. We have the queue, and in queue, the first item that is being added is A. Then it searches in depthwise. So after A, B is added in the queue, and after B, D is added in the queue. So there are no further child of D or neighbor of D. So from this point, this is the last element that is being added. It will be removed first, and our queue will look like this. That is A, B, and now neighbor of B will be explored. So the neighbor of B is E, and the child or depth of B is E, and further the depth goes to F, and after F is connected with C. So after F, C will be explored. So the sequence will be like this: A, B, D, E, F, and C. And the last element C will be removed, then it goes to F. F got no further neighbors. F will be removed. After F, E will be removed. After E, B will be removed. There are no further neighbors of B that are not explored. Then it goes back to A, and from A, C is in the visited list, so it don't goes on that side. So that's the traversing result. Let's check if it's correct or not. We run this code. The output is like A, B, D, E, F, and C. A, B, D, E, F, and C. So that's it. Thanks for watching.